Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning to all of you. So today we are going to discuss about 7.3 Principle of Conservation of Energy. So before this we have learned about the subtopic 7.2 about the potential energy and kinetic energy. So based on what we have learned before, that we have to know potential energy in this subtopic, we divided into gravitational potential energy and elastic potential energy. And after that, we have discussed about the kinetic energy. So for all of this energy, gravitational energy, and then elastic potential energy, and also kinetic energy, all of these have their own formula to calculate the energy that is being used. So I hope that you can understand and remember and know how to calculate by using the formula given. So for gravitational potential energy, the formula is given here, mgh, that is equivalent to the weight of any object that is moved times height. So m here refer to the mass, g refer to the acceleration of gravity, and h is height. So this is the formula that should be used to calculate gravitational potential energy. Okay. After that, elastic potential energy. So this is the energy that is caused by the compression or stretch by any spring. So to calculate this potential energy, that is elastic potential energy, is 1/2 times F force times X, that is the displacement that taken place from the equilibrium position in meter. And next, kinetic energy. Kinetic energy, the formula is 1/2 times mv square. So m refer to mass in kilogram, v is a velocity in meter per second. V is velocity in meter per second square. So this is the formula. So means that you have to remember three formula in order to calculate the different type of energy that we have discussed in subtopic 7.2. Now we will look into 7.3, the last subtopic in this chapter, energy and power, that is principle of conservation of energy. So this is the principle, this is the basic thing that you have to understand about energy. Exactly, energy have their own characteristic that we must understand, in order for us to understand the overall concept of energy itself. So in energy, we have a principle, we call it as a principle of conservation of energy. So what is the principle of conservation energy? So the principle of conservation of energy states that energy cannot be created or destroyed. So this is the important point given here in this text. Energy cannot be created or destroyed. So what does it mean? So we will means that energy is already exists. Energy is already exists, and exactly energy is created by God itself. Yes, all over the universe, in anywhere is exactly created by God. So that is the real situation that you must understand. But when God create all these things, so we can say that this energy exactly cannot be created by other energy, by other creature. Yeah? It already existed, it already exists in the form that created by God. So what you have to understand right now, based on the concept of sign, so what is already being created by God, we say it as a natural situation, natural condition. So this energy, when being created, so it's already there. So based on this situation, so we can say that energy that is exists is cannot be created from nothing. Cannot be created from nothing. So now this energy can only be transformed into other type of energy. So that's why in this principle of conservation of energy says that energy cannot be created or destroyed, but can only be converted from one form to another. So this is the point that you must understand in this principle of energy. Okay, so you have to remember this one. Very important. Principle of conservation of energy states that energy cannot be created or destroyed, but can only be converted from one form to another. So what is the example, simple example that we can use to discuss about this principle of conservation of energy? So what we have learned before about the potential energy and kinetic energy will be used to understand this principle of conservation of energy. So now, from here, okay, oscillating system, oscillating system such as oscillation of a simple pendulum and the oscillation of a loaded springs always experience transformation in the form of energy between gravitational potential energy or elastic potential energy and kinetic energy. So, from this situation, we can explain how energy is exactly can be transformed from one type to another type based on the situation. Okay, for example, in the oscillation system of this pendulum. Okay, this oscillation system using pendulum. So this pendulum ball or bob, okay, tied up with a using this one using a tie. Okay, this one maybe using a rope or thread. Okay, so this one will be hang to the one point, and then it will be turn like this and then release. Okay, so the movement of this pendulum from left to the center to the right will explain to you about the transformation of energy from one type to another type. So in this simple explanation, simple example given here is that the potential energy will be converted to kinetic energy, in which the kinetic energy will make the pendulum bob, move from left to right. Yeah? And then when this ball is at the static position, so at that position, the energy possessed by this ball is a potential energy. So from when we release the bob, the pendulum bob, and then it will move. So the movement of this pendulum bob is exactly the transformation of potential energy into kinetic energy. Yeah. So based on the position and the situation of this pendulum bob, so we can explain about the transformation or the principle of conservation of energy. Okay, so this is the explanation. Yeah. So condition of pendulum bob at a different situation, and what is the transformation in the form of energy for the bob between gravitational potential energy and kinetic energy. So you can read from here. Yeah. So the whole thing about this oscillating system want to tell you that energy can be transformed to another type of energy, and this energy is already exists, cannot be created and cannot be destroyed, but can only be converted, to another type of energy. So this simple explanation example will tell you about the principle of conservation of energy. So we look at the first condition here of pendulum bob at position X. So we look at here, pendulum bob at position X. So exactly before we do anything, the ball will be static here, and then by using our force, we put the position of the pendulum bob here, X. So when the pendulum bob at this position, X, so the type of energy that possessed by this pendulum, is the gravitational potential energy. So at this position, energy possessed by the pendulum bob is gravitational force of energy. So now when we release this pendulum bob, it will move from here. This arrow show the movement to Y, and then it will move to Z. Okay, so this is the movement. So based on this movement, from position X to Y, what happened to the energy? Gravitational potential energy of bob decreasing, and then the kinetic energy of bob will increase. So step by step, the potential energy, the gravitational potential energy, will be converted to the kinetic energy one by one, slowly, from higher potential energy to the low potential energy, and the decreasing of this gravitational potential energy is converted, changed to the kinetic energy, and this changing will enable the pendulum bob to move from X to Y. Okay, so now at position Y, gravitational potential energy is exactly at the minimum point of energy, and for the kinetic energy at this point, position Y, have higher or maximum possessors of energy, yeah, at this position. Yeah. So when from Y move to Z, what will happen is, yeah, from position Y to Z, gravitational force potential energy will increase and kinetic energy will decrease. Yeah, you can see from here. So that is what exactly happened during the movement from position Y to position Z. Yeah? So the gravitational potential energy will increase, and then the kinetic energy will decrease. Yeah? Until the ball or the pendulum bob reach the position Z. So at position Z, yeah, the gravitational potential energy at a high or at the maximum position, and the kinetic energy is exactly 0, yes, because no movement at all. Yes, so means the kinetic energy is 0, and the kinetic energy exactly being converted to gravitational potential energy. And then what happened? Until here, at position that Z, the maximum that can be reached by the pendulum bob. So at this position, as we have learned just now, this is the highest position of gravitational potential energy. So after that, this pendulum bob will move back to the position Y, through the step 3, from position Z to Y. So what explanation can be given here is that gravitational force potential energy will be converted to the kinetic energy, and then it will make the pendulum bob to move from Z to Y. So what happened to the quantity of the energy itself? Gravitational potential energy will decrease and the kinetic energy will increase. And at position Y, gravitational potential energy is at minimum, and then the kinetic energy is at maximum possession. Yeah? Okay, and then after reach position Y, it will move to the position X. So what happened to this energy? So gravitational force energy, potential energy will increase, and the kinetic energy will decrease. And when reached at the position X, so gravitational potential energy will be at a high or maximum possession, and the kinetic energy will 0. So this is the how to explain about the oscillating system using the pendulum bob, in which when we oscillate this pendulum bob, so the movement of this pendulum bob is exactly because of the changing of the different type of energy from gravitational potential energy to kinetic energy. So what you have to understand is at what position, what is the situation of gravitational energy and also kinetic energy. Okay, so this second example, oscillation of a loaded spring. So this spring also will show you about the principle of conservation of energy, in which it will tell you about the energy that will be converted from one type to another type. Okay, so same thing will happen. Yeah? So at different position, so you have to know what is the type of energy and what is the situation for that energy. Yeah. So in this concept, we are using spring. So the energy that possesses by spring is a elastic potential energy. So when spring is being compressed or being stretched, so it will possess elastic potential energy. Okay, now we will look into this oscillation of loaded spring. So at different position, you can see from here. So when spring is put with a load here, so this load will make the spring to stretch, and then the load will be at a different position. It will move to the bottom, so it will make the spring become stretched. So what is the conservation energy that can be applied in this situation? So you have to know spring will have elastic potential energy, and the movement of load to the bottom, and then it will come back to the early position is the movement of the load. Okay, so now at position X, okay, position X, so this one, position X, elastic potential energy is maximum. Spring is more stretched, and kinetic energy is 0. From position X to Y, here X to Y, okay, elastic potential energy will be becoming decreasing, and the kinetic energy will increase. So spring is gradually becoming less stretched, and the speed of the spring increase. At position Y, elastic potential energy is at minimum, and kinetic energy is at maximum. And then from Y to Z, from Y to Z, okay, from Y to Z, okay, what happened? Elastic potential energy will increase, and the kinetic energy will decrease. And then when reach position Z, it will coming back to the position Y. So elastic potential energy decreasing, kinetic energy increasing, and then it will reach to the position X again, from Y to X, from Y to X. So what will happen? Elastic potential energy increase, and kinetic energy decreasing. And then at position X, elastic potential energy will become maximum, and kinetic energy will become 0. So that is the situation to explain second example of energy conservation, principle of conservation of energy. Okay, so transformation of kinetic energy and potential energy in a closed system. So in closed system, in a closed system, the transformation of energy between potential energy and kinetic energy obeys the principle of conservation of energy. Therefore, the total potential energy and kinetic energy in a closed oscillation system is constant. The total potential energy and kinetic energy is constant. An example of a closed oscillation system is shown in figure 7.13. A and B shows so this shows the transformation of energy in a graph. Okay, so this one, by looking at this diagram given, so I hope that you can try to understand, try to read again the explanation given in the text, and then what exactly happened during the process of the oscillating system. So in BM we say sistem ayunan, berayun. So that ball will oscillate from left to right until it will reach equilibrium position, until the ball stop. So when the ball stop, means that the energy before that, potential energy, and then kinetic energy, and then at the last, at the end of the process, it will stop, mean that it will reach equilibrium position. At equilibrium position, so what will happen when this ball stop, means that no movement, so kinetic energy is 0, and then the potential energy is also 0 when stop. Okay, so that is exactly happen during the process in the oscillation system. Okay, so I know that this is a very exactly difficult concept to understand, but in this subtopic only tell you about the basic one concept of energy only. Exactly, we have lots of principle that related to the energy, and this one is principle of conservation of energy. So we have example of numerical problem here by using this pistol. So there is a calculation given here. So we are using the equilibrium. Means that the value of potential energy change to the kinetic energy is same. Is same. So when same, means that this is the equilibrium. Maksudnya sama. Energy before and energy after that have been changed, is the value is same. So that's why we can look here, the formula, the potential energy, elastic potential energy, half times Fx, so equal to kinetic energy, half times mv square. So this is the exactly what we say about the principle of conservation energy. Okay, so the energy before and energy after is same in value. So based on that, we can find anything relating to this energy. For example, in this situation, so calculate the maximum speed of ball of mass 550 gram when it is fired from the pistol. State an assumption that is made in solving this problem. So in this calculation, we want to know what is the speed of this bullet exactly. Bullet or the ball. Okay, because this is a toy pistol. So this is the plastic ball. So what is the speed of this plastic ball? So we are using this principle of conservation of energy. Okay, so we can find the speed. So the speed is V equal to 5 meter per second. Okay, so I hope that you can try to understand. If you can understand a little bit, so that is good for you. But in order for you to get more understandable about this concept, so try to do this formative practice 7.3, 1, 2, and 3. So I hope this simple explanation will guide you to understand about the concept of principle of conservation of energy. So I want you to do this formative practice in your textbook after you finish your notes for this subtopic. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.